Let's try our next example. This time, we're given the coding matrix and we are asked to decode this message. Okay, I know that message looks really long because there's 8 different numbers in the message, but that's okay. We're going to approach it the same way we do when we're decoding with 4 numbers. And to decode you need A inverse. Okay? When we code or encode, we use A as it is given. But whenever we're decoding A inverse, remember, we have the formula for a 2 by 2 inverse. We have 1 all over AD minus BC times our crazy matrix, where D and A flip-flop, and we negate on the back diagonal. So change the signs on the back diagonal. And in our matrix, the original, I'm going to label my little A, B, C, D. So we can plug in. We have A inverse is equal to 1 all over. We're going to have 9 times negative 2 minus B times C, 6 times negative 5. We wind up getting 1 all over negative 18 plus 30, which gets us 1 over 12. Times our crazy matrix, the 9 and the negative 2. Times our crazy matrix, the 9 and the negative 2 are going to flip-flop. Negative 2 comes up, 9 goes down. We change B and C signs. So negative 5 becomes positive 5, staying put. And the 6 in the top right corner becomes negative. So we're going to have 112 times our crazy matrix. And now we have multiplication by a scalar, which means that we are going to multiply everything in the crazy matrix by 1 over 12. And then we are going to reduce. So we're going to take everything times 1 over 12 and reduce. So we get A inverse is equal to negative 1/6 because negative 2 over 12, negative 1/2, 5/12 in the bottom bottom left corner, and then 3/4 in the bottom right, because 9 over 12. Before we go any further, we're going to check our answer in the calculator. Check your inverse. Okay. Now, you still have to show all of this work. You have to show it by hand, but we want to make sure that A inverse is correct. When it looks like this, remember, convert to fractions. And we have the correct A inverse, so we're ready to go to the next step. Our message matrices, there are 8 of these guys. Typically, we would split this starting in the top left and dropping down negative 131, then 129, negative 45. We've been working a lot with 2 by 2, so that would be our first matrix. And our second matrix would start in the top left with 84, negative 28, 273, and negative 121. We need to take A inverse times each of these matrices. So first matrix, multiplication. We're going to have A inverse first. A, whether it's A inverse or the original, is always first. And we're going to multiply that by our second matrix. 255, going down, negative 131, coming up, 129, negative 45. We have a 2 by 2, which means we're going to wind up with a 2 by 2. And if you're comfortable doing it this way, you can. Otherwise, you can do your own method as long as you show your work. Labeling, the top would be row 1. The bottom is row 2. And then labeling the columns, we have column 1 and column 2. And this just tells us how to do our multiplication. So in the top left corner, we're going to take our row 1, that negative 1 6, plus negative 1 half. And we're going to multiply that by column 1, 255, negative 131. And then we are going to take row 1 from the purple matrix, the negative 1 6 times something, plus negative 1 half times something, times our second column from the blue, which is 129 and negative 45. Since we took the first row times both columns, we're good to go to the second row. So we're going to have 5 twelfths times 255, because they're both first in their little circle, plus, because it's always plus, 3/4 times negative 131, because they're both second in their little group. And remember, the numbers in the parentheses need to be the same. If they're not, something went wrong. Go back and fix it. Now we need to take row 2 times column 2. So we're going to have 5 twelfths times 129 plus 3/4 times negative 45. And again, if what's in parentheses didn't line up, something went wrong. Go back and fix it. Let's figure out what these are. So we're going to go to our calculator. I have negative 1 6 times 255 plus negative 1 half times negative 131. And keep in mind that since we are decoding, all of our answers should be between 0 and 26. So our first answer that we find is 23. We're going to have negative 1 over 6 times 129. I'm going to go really quick here. And negative 45. And we get 1. Bottom left, we are going to take 5 twelfths times 255. We're going to take 5 twelfths times 255 plus 3/4 times negative 131, and we get 8. And we're going to take the same fractions times our 129 and negative 45, and we get 20. So our first answer is 23, going down 8, 1, 20. That is our first matrix multiplication. Okay. We still need to do our second matrix multiplication. We still need to do our second matrix multiplication. Okay. Now, if this whole 2 by 2 is throwing you for a loop, there is a way around this. You can take your A inverse and break up your second matrix. So we're going to have to do this twice. So what I mean by break it up is that a lot of students are more comfortable multiplying by a 2 by 1. A 2 by 2 is just two 2 by 1s smushed together. So if I'm looking at this second matrix, I can multiply A inverse times the 84, negative 28, 273, negative 121, just like I did in the first matrix multiplication. But if you're getting lost with that, break it up. Do 84, negative 28, and then 273, negative 121. Now here you have to do two multiplications that are separate, but some students really like this method better, because here we're going to take row 1 times column 1. Means we're going to have negative 1 6 times 84 plus negative 1 half times negative 28. And since we're done with row 1, we can go to row 2. We're going to have row 2 times column 1, which means we're going to take 5/12 times 84 plus 3/4 times negative 28. And again, they line up in the parentheses. Okay. If we go to our calculator, I still have my fractions in there, so I'm going to take negative 1 6 times 84 plus negative 1 half times negative 28, and I get 0. And in the bottom, I would have 5/12 times 84 plus 3/4 times negative 28 to get 14. And doing the multiplication in the last one, I would have row 1 times column 1, which gets me negative 1 6 times 273 plus negative 1 half times negative 121 all over. Row 2 times column 1 gets us 5/12 times 273 plus 3/4 times negative 121. So let's go back. We're going to take that negative 1 6 times 273 plus the negative 1 half times negative 121, the 5/12 times 273, and 3/4 times negative 121, which means we get 15 and 23. Now, the trick with breaking it up this way is that you have to remember the order. So our first 4 answers We're highlighted in yellow. And then we have our second 4 answers. So we had our first set of 4 highlighted up in yellow. And then we have our second set of 4 numbers decoded that we just found. So we need to find our message. And our message order is important. Starting with the top left of our first number, we have 23. Listing vertically, 8, 1, 20. And then the second matrix, whether you did it as a 2 by 2 times a 2 by 2, or you broke it up like this, either one is fine. We would have 0, 14, 15, 23. But this isn't a message. We still need to convert it back into the alphabet. Otherwise, nobody knows what we're talking about. So W is for 23. 8 is H. 1 is A. T is 20. 0 is space. 14 is N. 15 gets us 0. And 23 gets us a W. So our message is what now? Like, what are our next steps? Okay. You do have to show all your steps. However, you want to multiply the matrices by A inverse or A inverse by those matrices because A inverse has to come first. That's up to you, but you have to show all of your work. No work, no point.